Hey, we are talking today about compound events having to do with probability, which we've been studying in 7th grade math. So let's look at this problem. It says the three students chosen to represent Mr. Balderic's class in a school assembly are shown. All three of them need to sit in a row on the stage. Use a list, so specifically a list, to determine the sample space for the different ways they can sit in a row. Okay, so they suggest using A for Adrian, C for Carlos, G for Greg, which is great. So let's do that list. So we know it could be just Adrian, Carlos, Greg. Could be Adrian. I like to keep that first letter as consistent as long as possible. So it could be Adrian, Greg, Carlos. Let's look at the next letter. What about Carlos first, then Adrian, then Greg? And what about Carlos, Greg, Adrian? Okay, let's look at the last letter we haven't used in the first C. Greg, Carlos, Adrian, Greg, Adrian, Carlos. We have exhausted all of the possibilities, and we know that because we stayed consistent with this first letter. We started with the A's and exhausted those, then did the C's, and then the G's, and so we tried to swap up the letters in the second and third row. All right, so how many do we have? So if you look at this, 1, 2, 3, 4, 5, 6. So we have 6 different possible outcomes is what we call that, or the sample space. And we accidentally had not erased the sample space or the answer anyway, so this works out. So we can see that it consists of 6 outcomes. Now, technically, we could do it with do the same thing, even though this has for a list, which is what we've given. I could also do it with a tree diagram. So let's say we have Adrian, we'll have to list all the possibilities. Adrian, Carlos, and Greg. Then I could say, well, after Adrian would sit Carlos or Greg, and then from Carlos would be Greg over here, and then Carlos. So then you're just showing all the possibilities doing it in this way. So that would be Greg. Just make sure you don't accidentally repeat anyone. And so again, and this is kind of a weird way, honestly, to use the tree diagram, but it can be used this way. Okay, so in the end, using the tree diagram, you see there are 6 options here. And 6 possible outcomes, which makes up our sample space. In this case, it makes a lot more sense to use the list, which is why I'd asked you for that. Let's look at the second problem I have here. So it says the 3 students chosen. Oh, we actually just solved that one. Let's look at the next one. All right, our next problem says a car can be purchased in blue, silver, red, or purple. It also comes as a convertible or hardtop. Use a table or a tree diagram to determine the sample space for the different styles in which the car can be purchased. And I went ahead and left up the table that they gave. So they gave all the different options. So this is another way to list out your different options. So they have blue convertible versus blue hardtop, silver convertible, silver hardtop. Okay, I also wanted to show an example of a tree diagram. So first we want to start with our categories. So we have the color that we're going to list on the left, and then the tops will be in the middle, and our sample space will be there on the end. Okay, so our color options, we have blue. You might notice actually colored over it earlier, so end up erasing it to get the actual answer. It's a little weird. But anyway, so I have the blue, silver, red, or purple are my options, which is given in the problem. But then I have 2 branches off of that because I can do a convertible or a hardtop. So I have to show that on the tree diagram. So convertible or hardtop. And I have to do that on every single one of these. So convertible and hardtop. Okay, so my sample space is how many of these options we have. So they just rewrote that letter out there. So rewrote the letters. So for blue convertible, they just made BC. And then, blue hardtop would be BH. Okay, so then in the end, you end up counting that last column, which makes up that the sample space. Another option is once you've exhausted all the different things. So all we had was the color in the top. Sometimes you have multiple different levels with compound probabilities. So we could have had a third level. So let's say you had the 2 different hard tops, and then some other feature that was really cool, like
Sure.
4-door, 2-door. So we have, we could have extended that a little bit further. But for now, we just had the 2 levels in this problem. So we do count it up and we see it. There's 6 in our sample space. And we've used that, we've shown that with the table as well as our tree diagram. So hopefully this was a good refresher on how to do compound inequalities and to show the sample space in a variety of ways.